Thank you for joining the presentation about Digital Core Analysis with GeoDict 2022. My name is Christian Hinz and I started working with GeoDict in 2015 at the University of Mainz. In 2019, Math2Market hired me as application engineer for digital rock physics. And since spring this year, I'm responsible for the entire DRP team at Math2Market. This user meeting session is all about digital core analysis. So before we go into detail, let's first have a look at the very basic digital rock physics workflow. In principle, any digital rock analysis workflow starts off with obtaining and preparing a rock sample. This is followed by image acquisition via microCT, FIB-SEM, or any similar device, aiming at obtaining a proper 3D gray value image of your rock sample. This is the point in your workflow at which you might want to import your image into the GeoDict software to perform 3D image processing and segmentation. With a thus obtained image consisting of pore, solid, and maybe also microporous materials, simulations of the physical properties of any rock sample can be carried out with GeoDict. The reason why you do this digitalization is fairly simple. It saves time and costs compared to conventional lab experiments. At Math2Market, we are working hard to make GeoDict your solution for digital core analysis. So in the upcoming minutes, if you're not yet convinced, I would like to convince you of the GeoDict standard for your digital workflows. And in fact, there are lots of arguments and features making the GeoDict software package unique. And in the following I will focus on general highlights and subsequently advance to the technical features of GeoDict. In GeoDict, you will always perform direct numerical simulations. So the GeoDict solvers consider the entire complexity of the structure to compute physical properties. Our solvers perform very well, even in challenging 3D images of digital rocks or soils and at sizes beyond 2000 voxels on each side, or even 4000 voxels when it comes to absolute permeability. So in other words, with GeoDict you will get the desired precision at optimum runtimes. Our philosophy is to answer all your questions with respect to your application of the GeoDict software. We want you to benefit from our professional support to help you analyze your digital cores accurately and efficiently. So we think that this is the best way towards a win-win situation for you and us. Whenever you have set up a proper GeoDict workflow, you may automate it via our Python interfaces to increase your productivity or to just have more coffee breaks. So to be honest, it may take some months to achieve this step, but having done so, we are the right partners to advance your digital workflows to cloud computing, to provide you with a maximum efficiency and to put you more than one step ahead of your competition. Just to provide you with a reference, have a look at selected GeoDict users from the oil and gas industry and academia. So we have a continuously growing number of GeoDict users and many well-known names. And as usual, we may not show all the logos of our clients, but we also have large companies in all of the other business areas at Math2Market. In the next couple of minutes, I will dive into the technical features for the most prominent GeoDict capabilities for digital rocks and soils. And I will start off with 3D image processing and segmentation. In GeoDict, you may import any kind of 3D gray value image data. And even if you're keen enough to find a data format that we have not yet considered, we will make it happen. Just let us know. Our image processing toolbox comes with typical features to analyze your images, process your images, and segment your images. Please note, our image filters are uncontented in performance and they are applied in the entire 3D domain at once. For image segmentation, we also offer AI image segmentation with machine learning and deep learning algorithms. For digital sandstones, we also offer an image quality check. So just to provide you with a better understanding of your 3D digital sandstone data once you've segmented it. And having obtained a structure model in GeoDict, one may advance to geometrical characterization and the prediction of physical properties. And that's basically what we call digital rock physics. With the GeoDict modules for geometrical characterization, you may characterize any porous media. You may analyze the pore space and material distribution. You may identify individual pores and grains. And new to GeoDict 2022, you may also identify fractures based on characteristic thresholds. And last but not least, you may generate digital models or even statistical digital twins of your reservoir rocks. So we do not list all the individual features here, but rather claim that you may obtain all the geometrical information that you need. In the field of property prediction, the absolute permeability is probably the most prominent. So any digital rock physics software has a feature to determine the permeability, of course. But what makes GeoDict the favorite choice amongst all the options? So I'm going to tell you. In GeoDict, you may consider microporous images at micro and nanoscale. You will achieve results faster with a higher memory efficiency in larger geometry dimensions, going beyond 4000 voxels in each direction. And of course, GeoDict produces accurate and reproducible flow results. And with GeoDict 2022, we have even improved the performance, especially in challenging domains such as tight rocks. More details about this will be given by our expert Sven Linden in the upcoming talk. One of the most important features for digital core analysis is, of course, two-phase flow. And you may compute this in GeoDict and even animate your results. So what we do is the direct numerical simulation of two-phase flow. So we simulate directly in the voxel geometry. This means that in contrast to pore network modeling, we do no simplification at this point. Instead, we use the pore morphology method, which is a morphological approach that we have extended by dynamic features in the past years. And with a set of tools in GeoDict, you may compute drainage and imbibition, and any combination of these, such as gas trapping curves and the entire hysteresis cycle. In a two-phase flow computation in GeoDict, you may consider any wettability, no matter if water wet, oil wet or mixed wet. And in GeoDict 2022, we have a large number of new developments. So you may now consider mixed wettability. We have improved the overall performance. We now allow contact angles in the entire contact angle range. And we have implemented a dynamic transition from spontaneous to forced imbibition. And yet again, please expect more details on two-phase flow in GeoDict 2022 in the upcoming presentation of Sven Linden. The digital mercury intrusion capillary pressure curve is probably one of the first features to be computed in a digital core analysis workflow. When you execute such an MICP experiment in your lab, you may know the unresolved porosity in the corresponding digital rock structure, so the porosity that is below the voxel resolution. Knowing this is of paramount importance for your entire digital rock analysis workflow. And in GeoDict 2022, you may now predict this unresolved porosity via application of the Tromare model wherever applicable, so mostly in case of conventional reservoir sandstones. And here's the story. So back in 2016, Steffenberg et al. Discovered a mismatch between experimental and digital MICP results. It took a while to understand that this issue related to the unresolved porosity, and indeed by just plotting the volume percentage on the x-axis instead of the saturation, the curves do now agree perfectly fine. So this is one basic step that you need to consider in your digital workflow. GeoDict 2022 now also offers another possibility. By applying the Tromare fit, we now predict the unresolved porosity for your digital rock in addition to the MICP curve. Try this out yourself in the digital physics workshop later today. In GeoDict, the relative permeability is computed based on snapshots of the two-phase flow simulation, as shown here for an effective water permeability in an intermediate step of a primary drainage. And that's what we do. Predict the effective and relative permeability of a digital reservoir rock from the computed sequence of fluid distributions. So, with respect to digital water flooding, you may compute enhanced oil recovery setups in GeoDict. And you may automate that task from within GeoDict, which opens up the possibility to perform your individual uncertainty analysis for challenging domains. In GeoDict 2022, we have further improved the performance of this step with the new advances in our flow solver. Based on two-phase flow results, you may also predict the resistivity index. And in addition, we calculate the cementation exponent as well as the saturation exponent. As another electrical property, you may also compute the formation resistivity factor. In addition, we have a feature available for consideration of thin water films on your solid surfaces that does have influence on computed properties, even with nanoscale water films in conventional reservoir sandstones. And this is shown here. Thin water films computed in the Berea sandstone reduce the resistivity index to 1/3 of its original value. GeoDict capabilities for mechanical properties in reservoir rocks comprise, for example, the determination of the overall mechanical properties. You may also compute deformation and failure upon application of mineral-dependent compression strengths, which is providing you with a stress-strain curve, the 3D Farmese stress distribution, and also the computed failure locations in 3D. In GeoDict 2022, we now offer a strongly improved performance for digital nonlinear mechanics. And for more details, please also join the digital material R&D session. Our focus at Math2Market goes even beyond these excellent technical solutions. Our philosophy is to offer a complete all-in-one solution for your digital workflow, featuring the technical capabilities, professional support, and automation to increase your personal productivity. Automation in GeoDict is done with GeoPy, the GeoDict Python interface. And with GeoPy, you may automate common and repetitive tasks. You may analyze your setup by easily performing parameter studies. You may even generate PowerPoint reports filled with results of your digital workflows. And you may apply the entire range of Python coding to do so. With the capability to access any kind of GeoDict result data, you can basically automate just about everything in GeoDict. The reactive flow feature is just one example of a GeoPy script that's working very well. And once you have your workflow set up, you may advance to cloud computing with GeoDict. Get more details about cloud computing in the talk of our cloud expert, Rolf Westerscheiger, in the image processing session. You have any feedback on the GeoDict capabilities for digital core analysis or any questions, please contact us. And thank you for your attention.